Hello everyone, welcome to another video of my channel. Today I'd like to discuss on a problem named Valid Palindrome 3. Leetcode problem number is 1216 and it's a hard categorized problem. The problem says given a string s and an integer k, return true if s is a k palindrome. By k palindrome it means that a string can be made palindrome by removing at most k characters from it. So let's see some example here. In this first example, our given string is ABCDECA and the value of k is 2. That means we can make the string as palindrome by removing 0, 1 or 2 characters from it, then we will return true. Otherwise, if we need more than 2 characters to be removed from the string to make it palindrome, then we return false. Now if we remove B and E, this B and E from the string, then it becomes ABCD CA. That means it becomes a palindrome string, and we could make this string palindrome by removing only 2 characters. So this is true. And similarly in the second example, if we remove a single B from it, that means by removing a single character, we can make this string palindrome too. So here we also return true. Now let's try to solve this problem. Our first idea is that we will find the minimum cost to make the string palindrome and then compare it with k. That means while calculating the minimum cost of the string to make it palindrome, we do not compare the value with k. We simply find out the cost and at last we compare with k. If the cost is smaller than or equal to k, then we return true, otherwise we return false. We solve this problem using bottom-up dynamic programming approach. That means we'll have a table, DP table or say memoization table, where we will try to fill up the value of the table from bottom to top. Then what we will do is find the cost of the string from smaller to larger gradually. It means that we will start from the very last character of the string, since we are going from a bottom-up approach. And the last character of the string means there is only one character and it is by default a palindrome. So we have 0 cost. That means we need to remove 0 character to make this string palindrome. Then gradually we'll increase the length of the string and finally we will find out the ultimate minimum cost. So in order to use this approach, we need 2 things. We need the base case and we need the recurrence relation. And we got our base case, that is when the number of character in a string is only 1, it is by default itself is a palindrome. So our cost in that case will be 0. Now let's find out the recurrence relation. Say in this string, let's try to find out a palindroming string or k palindroming string. What will be our approach? We take 2 indexes, say I and j. If the character set I and jth index are equal, then we can say that we do not need to remove any character. So our cost at this position will be 0. Or we can also say that the cost will be same as for indices this one, that means I plus 1, and this one, that means j minus 1, because at this position whatever is the cost, that will be same as for this ith and jth index, because the ith and jth index position cost us 0. So we got if characters at I and j index are equal, then the cost will be similar for those at indices I plus 1 and j minus 1. What if both characters are not equal? In such case, say I is at this position at A and j is at this position at B. Since both characters are not equal, we will have to remove one of those characters. What we can do is we can remove this character at index I, or we can remove the character at index j, that is B. But we do not know which way moving forward in which way will lead us the minimum cost. So we will consider both scenarios. That means we'll remove the character at index I, that means A, and we'll proceed forward. That means we increase the indices of I from I to I plus 1, and we consider the string from I plus 1 index to j index, or we can decrease the position of j. That means we consider the string from the indices I to j minus 1. And since we considered both the cases, we will take the minimum of those cases. And since in each cases we decrease one, we remove one character, so we will add 1 to our cost, which means if the characters at indices I and j are not equal, then the cost will be 1 plus the minimum of cost between I plus 1 to jth index and I to j minus 1th index. Let's try with an example to make it more clear to you guys. Let's apply our process to this example. Here you can see a given string s, a b c d c a, and we have created a 2D array named dp having rows and columns equal to the length of the given string. Here we'll be using two variables I and j, where I represents each column of the table and j represents each row of the table. Now initially the value of each cell of this dp table will be 0. Now we move from bottom to top, so the value of I will be length minus 1 to 0, and the value of j will be I plus 1 up to the length of the string, which means this is that point at the very start. Now here we can see that we have a, and in the top we have a, which means the cost here will be 0. In fact, in all this diagonal position the cost will be 0, because here the value of I in each of these diagonal cells, the value of I and j are equal. That means same character is being compared. What we do, we start from this cell. Here we can see that we have C, and in the top we have A. That means here s of I is not equal to s of j. That means we will apply this second recurrence relation. That means the cost of I of j here will be 1 plus minimum of dp I plus 1j. If this is the ij cell, I plus 1j means the cell just below this cell, and the dp I j minus 1. By j minus 1 we mean this one left to this cell. So the minimum between these two cells is 0, and plus 1 means here we will have 1. Now the value of I will also decrease. That means the value of I will be, let's see what will be the value of I. Here the value of I will start from length of s minus 2 to 0. The length of s is 7, so we know the index starts from 0. If we start at this row, that means length of 7 minus 2, so the values of I starts from 5. And for each value of I, the value of j will start from I plus 1 up to the length of s minus 1. At first the value of I was 5, now it decreases to 4. This is the 4th index, and the value of j will be 5. So we get 0, 1, 2, 3, 4. This is our row number, and as the value of j is j starts from I plus 1, that means 5. So by 5 we mean this one. In this cell we can see that we have E and at the top we have C. E and C not being equal, we'll apply the similar process. That means we will compare the value between this cell and this cell, and we'll take the minimum of them. The minimum of them is 0, and we'll add 1 with them. Now we are coming to this cell. In this cell, E and A are not equal, so similar process. Here we can see we have both 1. The minimum of 1 and 1 is 1, and we add 1 with them. That means it becomes 2. Now again the value of I decreases from 4 to 3. That means 0, 1, 2, 3, this row, and the value of J will start from 3 plus 1. That means 4. So 0, 1, 2, 3, 4, this cell. Here if we have a look at, we have D and E. That means they are not equal, so here the value will be, we know, 1. Now here in the next cell, D and C, same case, not equal. The minimum of them is 1, and we add 1, that means 2. Now in this cell, D and A not equal, it will become 3. Now again the value of I decreases, so it will be this row. So the value of I is here 2, and the value of J will start from 3. That means this cell. Here also we have C and D, they are not equal, so we have here 1. Similar case in this cell also, we have here 2. But here is an interesting thing. If you have a look at this cell, here we have at the top C, and at the very left we have C. So both of these characters are same. So what will happen? Here we will have the, according to our recurrence relation, we simply take the value of the next row and the previous column. By that we mean, if we are in this cell, the next row is this bottom row, and the previous column of this is this one. That means these two matches at this cell, the cell in this position. So we have 1 here, so we will take here 1. Now in the next cell we have C and A, they are not equal, so the minimum between this cell 1 and this cell 3 is 1. We take 1 and add 1 with it. That means it becomes 2. Now the value of I decreases to 1, and the value of J starts from 2 to up to 6. So we start from this cell. Here we can see B and C are not equal, so the value here will be 1. Again B and D not equal, so we get from these two cell 1, and adding 1 we get 2. Again B and E not equal, we get 3 here. Now again B and C not equal, so the minimum between 3 and 1 is 1, plus 1 is 2. Now at the very last cell, B and A not being equal, we get the minimum 2 plus 1, so 3. Now the last loop for the I, because it becomes, the value of I is now 0, and the value of J starts from 1 to 6. In this cell we can see it will be 1, in this cell it will be 2, in this cell it will be 3, in this cell 4, in this cell 3, because the minimum between these two is this cell 2, and plus 1 is 3. Now at the very last cell, at the very last iteration, this particular cell will give us the answer. By the answer we mean the minimum cost to make this string a palindrome. Now here in this cell, A and A are equal, so what we do, we take the value of this very cell, which is 2. So here we get 2. So our process returns 2 from this string, and our K was also given as 2, so we return true. Now it's time to find out the running time complexity and space complexity of this algorithm. Here we can see that the value of I iterates at most, say, n times, where n is the length of the string, and for each value of I, the value of J is being iterated at most, for the very last case, n times. So our time complexity is O of n square. And if you have a look at this 2D array, we can see that the space complexity is also O of n square. Now let's solve this problem in Leetcode. Here you can see our solution. I have written the code the way I discussed it. At first I have taken a 2D vector, initialized it with 0. Then let's see, the value of I starts from the length of the string -2 up to 0, and for each value of I, the value of j starts from I plus 1 up to the length of the string. And if they are equal, so we take the value from the I plus 1 and j minus 1th index. If not equal, then we take 1 plus minimum of I plus 1 j index or I j minus 1 index, and at last we return cost found by us and is it less than or equal to k. Now let's run it, or let's submit it and see what we get. So we got accepted. I hope you guys have understood the problem. Thank you. Thanks a lot.